All right, we're back. It's already week 2. That was pretty quick. So we are going to assess those isolated samples, assessing the weight of the isolated sample, the melting points, and the TLC analysis. So right now we are isolating the salicylic acid. So we are scraping the salicylic acid off of the filter paper into a weigh boat. This had a full week to dry, so essentially that solid is basically crumbling off the filter paper, and it looks like we isolated 0.48 grams of the salicylic acid. So again, 0.48 grams of the salicylic acid. For the caffeine, that paper does not look very good. So the paper looks like it's pretty much crumbling off with the solid sample that we isolated. So possibly the paper maybe, and you can see actually it looks like that we don't have just solid particles. That was 0.58 grams. And you can see that with that, there's paper right underneath some of the crystals that you see. So you're essentially seeing for the caffeine, a mixture of paper and crystals. For the salicylic acid, just salicylic acid. Also, again, like I said, for caffeine, that was 0.58 grams, which is quite a bit. So when you calculate the percent recovery from that, you're going to see that the percent recovery is pretty high for caffeine, almost 100%. We've put the melting point standard adipic acid in a capillary tube that has a melting range of 151 to 154 degrees Celsius. Now we're going to put the cap back on adipic acid and get a small sample of salicylic acid in our melting point capillary tube so we can assess the melting temperature for our salicylic acid sample. All right, so what we have here, looking at the melt temp apparatus, so basically this is a phone video looking right into what you would see if you were looking in the hole of the melt temp apparatus. We have adipic acid on the left. So adipic acid is in here. So that tiny little glass capillary tube that you saw, where we got the solid at the bottom of it, with one closed end, one open end. This is the bottom at the closed end in our melt temp apparatus. This is adipic acid on the left, and this is our isolated salicylic acid in the center. So adipic acid has a melting point of 151 to 154. You can't see the thermometer, so I'm just going to tell you what temperature it is once we start seeing things happening. So you can see that there's a little bit of shift, specifically when you look at the adipic acid. It doesn't look quite the same, but I don't see any liquid that is formed yet. We're getting closer. It's settling even more. I still don't see any liquid. Okay, now I'm starting to see liquid form. So you can really see like a glowing reflection off of it, and you can start to see a little bit of liquid coming down to the bottom of it. That liquid layer essentially keeps growing and growing as the top area keeps sinking and sinking. So again, the temperature at which this started is 151 degrees. It keeps shrinking as it's slowly melting, as the temperature slowly rises. So it's essentially still in the process of melting. We're moving the thermometer. Essentially, the heat is set at a relatively low setting. The thermometer is moving up very slowly. That's good. You essentially need to allow the time for that level of heat to do what it can do to that compound. You don't want to skyrocket the heat because the thermometer can't keep up with what the temperature actually is in that metal area of the melt temp apparatus. So right now we're at about 152.5 degrees. All of our adipic acid has not melted. Our salicylic acid definitely has not started melting at all. All right, the adipic acid is getting pretty close. It's almost all the way, but it's still solid. I can't see through that layer, so we still have some solid there. That was just an issue of the phone going off for just a second. The light source on the camera. Okay, so at this point, I can't see any solid in there. It's not super clear yet. It's very close to the end. All right, now I can fully see through it. So that is the end. So that temperature, which now is 154 degrees Celsius, is the end temperature, which actually matches up perfectly with what it should be. So our melting point standard in this case is telling us that the temperature at which the standard should start melting at, and the temperature at which it ends at is exactly right on to where it should be. So when we look at our corrected values, there will be no corrected value for this because our adipic acid, our pure standard that we took, melted when it was supposed to start melting and ended melting when it was supposed to stop ending. So that basically tells us that our thermometer is right on where we want it to be. All right, so for salicylic acid, hopefully you've looked up the literature value for salicylic acid, but it should start and end very close to about 159 degrees Celsius. We need to let the thermometer rise a little bit more before we reach that temperature. But as you look at it, you can kind of see it's starting to settle a little bit. So it looks like overall it's not taking as much volume, specifically the outer area, which is exposed to the most heat because that's where the metal is that's being heated, is definitely starting to feel it. I don't see any liquid yet, so I wouldn't necessarily say it's starting at this point. Okay, now it's starting to melt. So now you can really see that white area. So essentially all of those crystals essentially are not there anymore. They're just melting into a liquid, which is why there's so much less area around that. So that's a good start temperature for the melting range of this. So it started at 158. It's definitely melting very quickly now. There's absolutely no doubt about it. We're at about 158.5 right now. You can see the liquid accumulating at the bottom very clearly. And now we're at about 158.9 and 159 degrees Celsius, 159.1, and it is fully melted at this point. So all of our salicylic acid is now melted. So again, that melting range for salicylic acid was 158 to 159. For adipic acid, it was 151 to 154. So for the melting temperature for caffeine, we are going to use caffeine as our melting point standard. The melting temperature is 235 to 237. It's always great when you can use a melting point standard, which is exactly the same melting point as the compound you're analyzing, which we're analyzing caffeine. So we've got our melting point standard prepared. And now we're getting some of our caffeine, and you can see we're basically puncturing holes through the layer of a small layer of crystals and a layer of paper, and it's very hard to get this actually to the bottom. We actually had to drop that in a long glass rod to get it to the bottom. So the caffeine sample that we isolated from the experiment is on our right. The pure caffeine is on our left, and you can see significant difference even just looking at these two. So like I said again, there is filter paper in this caffeine here. There is not any paper in this. This is the pure caffeine, our melting point standard. We've zoomed in here to get a close-up view of the two samples. So we just need to watch and see when they are going to start to melt. You can see on the right, it looks like some of those crystals are getting a little bit more transparent, especially if you look at the bottom. You can almost start to see through them just a little bit. And then the one on the left, so our melting point standard, looks like that sample is settling just a little bit. So everything's starting to settle a little bit more. And you can start to see a little bit more distinction between the actual paper and the crystals for the sample on the right. So the crystals, like I said, are a little bit more transparent. They almost look like ice sitting on the outside of the paper, but again, we still have not yet started to melt. Now for the sample on the right, it looks like things are about to start happening, but I don't see anything for sure yet. Okay, now it looks like we've got liquid forming. So those clear crystals, like I said, were definitely forming liquid. We started at 228 degrees Celsius. So at 228 degrees, that's when things started melting. I can still see some crystals at the bottom. Some of those crystals on top are basically falling down to the bottom. And it looks like the last of the crystals are melting. So all of those crystals have melted. We're at 232. And on the left, you can see those crystals starting to melt too. So I would say right when the sample on the right ended, that's when the one on the left started. So for the sample on the right, we melted from 228 to 232 degrees. And for the sample on the left, our melting point standard, we started at 232. Currently, the thermometer says we're about 233. Everything has not yet melted. We're still at about 233 degrees Celsius. Okay, it looks like it's all going to melt here in the near future. It's a relatively small sample, so that's good, a good representation. Alright, there's still a few crystals in there. We're still at the high end of 230, 33, 234 now. Okay, still at 234, and now it looks like everything has melted to the left. So at 234, everything has melted. Now, when we look at the right, so if I saw this and wasn't sure there was filter paper on it, I would still be questioning some things. So you've got some solid suspended up on that paper having no contact with the surface of the glass. So I think that's why you see a little bit more starting to slowly melt in there. You can't count that because it's not an equal representation as compared to our standard, because for our standard we don't have paper suspending additional solid. But you can still see some things are slowly melting off that paper. It seemed like it's very intertwined with that paper, so that's not too surprising. But we let the temperature keep going just to confirm and be sure that we did indeed have that paper there, and it looks like we did. All right, now we're to the point where we can prepare our samples for thin layer chromatography. So we took a little bit of the caffeine sample, and now we're going to dissolve that caffeine in some methyl acetate. A tiny spatula tip was taken to put in that test tube. That probably wasn't enough, considering we've got about 50% filter paper, 50% of our caffeine. I would say that most likely we don't have quite enough for the sample to show up on the plate. I'd recommend probably doing about 4 times that much solid based on that amount of solvent to spot on the plate. We'll see how it looks once they spot, but that's just my guess. For salicylic acid, this is 100% salicylic acid here. We found out from the melting temperature that it's pretty pure, so I think if we just use a little bit of that, we might be able to get by with it. But again, that was a pretty tiny amount, so I would say, again, probably about still 5 times that amount. If you just take one tiny spot on the plate, you can always check it, and if you're still a little bit low, you can always respot. Now, it's good not to overload it though, so you wouldn't want to take like a huge spatula tip and dump it in there, because if you overload it, you can't just spot again to add more. You've already overloaded it, and your plate's not going to run very well. Alright, so this is the original vial that we took, so that had our 1-to-1 mixture of caffeine and salicylic acid in it. We're just going to add some solvent directly to that. It looks like the amount of solid in that is substantially more than the tips that we added, so I think if we add a small amount of solvent to that and we dissolve all that compound, that's probably a good amount to spot. So I would guess we're probably going to see that spot on the plate when we spot it. Alright, so now we're getting our TLC plate out. The TLC plate has a plastic side and a side with silica gel on it. So the super shiny side, that side right there, is the plastic. The side that's facing up is the side with the silica gel on it. So when you draw your very, very faint lines on that and then spot your compounds on the plate, you definitely want to be on the silica gel side. So not the shiny plastic side, on the side where the silica gel is adhering to that plastic backbone of it. So it looks like we've labeled, we've got caffeine on the left, caffeine salicylic acid mixture in the middle, and salicylic acid on the right. It looks like the pencil line was a little bit too much, so you can see some of the silica gel off the plate. You probably want to draw quite a bit lighter than that. So even if you can't, even if it's not super clear what the labels are, if you can just barely read it, that's all that's necessary. You don't want to alter the silica gel in any way. But basically what happens is if you scrape it off the plate, your solvent's not going to run evenly up the plate because it doesn't have enough silica gel to adhere to. We're getting some of the dissolved caffeine, and we are going to spot that on the plate. So with these micro capillary tubes, we've got 2 open ends on them. We're just going to dab that down onto the plate, and liquid is going to run out onto the silica gel. It looks like that was slightly overspotted. So, and also, since that line was drawn so sharply, a lot of the liquid basically flowed into that little area where the pencil line was that's just plastic, so it couldn't spread evenly through the silica gel. So I would probably essentially just not hold it down on the plate that long. You can always hold it down, let it dry, and then spot again. That was a pretty good spot, so that's even a smaller one would be okay, but that one was pretty good for that one. And again, if you basically spot it, lift it up, let it dry, spot it, lift it up, let it dry, you can essentially get double the amount of compound there with having a much smaller area, which it's easier to read what your spots will look like under the UV light before you run the plate and after you run the plate if you make your spots very small and definitive. So now we're getting some of the salicylic acid and spotting that. So we'll look at this under UV light and see if we can see the spots. Okay, so it looks like you can see the mixture of 2 compounds pretty well. You can see that spot, but you can't really see the caffeine or the salicylic acid spot. So those definitely need to be, both of those need to be respotted, because if you can't see it at the baseline, you're not going to be able to see it once it runs up the plate either. So here we're getting a little bit more caffeine, putting that into our original solvent mixture. We're going to spot that again on the plate. We'll do the same for salicylic acid. Now, right now, what I'm seeing here is that actual UV light in the background, you can see that purple light there, that is on. That's not good. So we definitely want to have that off. It looks like it's actually visually into the camera. And if you look at that UV light, that's going to cause significant damage to the eyes. Okay, so we've added more caffeine into the solvent. That's now dissolving in that solvent. And we're going to do the same for salicylic acid. So if you were going to do this lab, then you'd have visual observations of about how much solid you should add in. And like I said, it's okay if you're a little bit concentrated with compound dissolved in the solvent, because you can just make one tiny spot and be done, check it under UV light, and you're good to go. And if you need to spot a little bit more, then you still can. And the reality is, even if more compound wasn't added here, if it would have been spotted another 10 times or so on the plate and then just let it evaporate, you probably could have had enough compound in both those lanes, because you could see a very faint amount of both caffeine and salicylic acid on the plate. So it's really just based on personal preference, but might as well be quick. Now that we've respotted the plate, it looks like we have 3 distinct and clearly visible spots under UV light. So now we can allow the solvent to carry those compounds up the plate, and we can assess the RF value of those compounds. We're going to put about 10 milliliters of solvent at the bottom of that 250 milliliter beaker. And with that plate, it's always good to double check to make sure that your line where you've got your spotted compounds, or even more than that, even the bottom of the spot, when you look at that spot under UV light, you want to make sure that you do not submerge any of that spot in the liquid. So you can see there's definitely a space between the bottom of the 3 spots and where that original solvent line is at the bottom. So now that we have that, the solvent is actually running up the plate and pushing compounds up the plate depending on how well or how not well the compound interacts with the solvent and how strongly the compounds interact with the silica gel on the TLC plate. So for the TLC plate, if you have a very polar compound, that is going to have strong interactions with the silica gel on the plate, and it will not be pushed up as far. It actually takes a while for this to run up the plate, but we took a little bit of the video out. We're now at a pretty good stopping point. We are at about just above 75% up the plate. I would say we were about 80% up the plate. So that's a good time to stop and draw the line, draw the pencil line for where the solvent stopped. We need that because when we calculate RF values, we need to be able to assess the distance the compound ran as well as the distance the solvent ran from the point of the spot to the top of where that solvent ran to. That is what it looked like after it ran without looking under UV light. That is what it looks like under UV light. So there you can see that our caffeine has one spot, our mixture has a spot, which is caffeine and salicylic acid, and our final spot with salicylic acid is just salicylic acid. So we actually did separate the compounds pretty well based on this TLC result. We isolated caffeine and we isolated salicylic acid, and if you stop the video here, you can calculate the RF values for those compounds by looking at the starting point, which is where we spotted the compounds. So on that baseline where we spotted the compounds, you take the distance from there to the distance of the solvent front. And it looks like the distance the solvent traveled was 39 millimeters. And then when you're calculating the RF value for your caffeine, you're going to look at the middle of the caffeine spot. So it looks like the middle of that caffeine spot is about 11 millimeters or 1.1 centimeters. So in this case, you would take 11 over 39, and that is the RF value for caffeine. For your caffeine and salicylic acid mixture, you would give 2 RF values for that. So you'd give the RF value for caffeine, which is the same as what we just talked about, that spot's in the same place, as well as the RF value for salicylic acid. So I'd want 2 values for that when you're looking at that middle spot with 2 compounds.